right, so take a look at the problem of the day, pause the video and solve it. Today we're going to take a look at lesson 4.7 called Complete the Square. So we're going to do a combination of factoring with perfect square trinomials and solving algebraically. So let's take a look at part one. Part one says, already given a perfect square trinomial. So I ask you the question, can you factor the left side? Well, if we take a look here, this here is a perfect square trinomial. And if you remember, we would do the parentheses, the quantity squared, go to 25. So I would have what? An x in each parenthesis. The reason it's quantity squared is because they're both the same. Signs are the same, they're both negative. 16 is 4 times 4, it's my perfect square. So what we're working with in this lesson is our perfect square trinomial. We factor the left-hand side, and now we're going to solve algebraically. So to get rid of the square, we do the square root, both sides. I get x minus 4 equals, now don't forget your plus minus, 5. Then I bring the negative 4 over as positive in front of the plus minus. But don't forget, because they're both whole numbers, I want you to give me my final answer. So it's 4 plus 5, and 4 minus 5. So my final answer is going to be 9, negative 1, or negative 1. A lot of times you'll see I do a little parenthesis or a comma to signify that. All right, so try letter B. Take a second to do it yourself. You might want to pause the video to see how it goes. It's x plus 3, quantity squared, equals 36. Take the square root of both sides. Oops. Get x plus 3 equals plus minus 6. Don't forget, because they're both whole numbers, to simplify once I write this. Negative 3 plus minus 6. Get your two answers. X equals 3, negative 9. So this is how we solve these kinds of problems. Now, this is when there's a perfect square trinomial on the left. But what if there isn't one? We could actually make any factorable problem, or any quadratic, I should actually say. We could force it to be a perfect square trinomial. So let's take a look at it here. It's called completing the square. Here we don't have a third term. We have x squared plus bx. There is no c. So we're going to actually find out what c is. It says add b divided by 2 quantity squared. All right? I'm going to show you guys how to do it. The b obviously is attached to the x, right? So part 2, we're going to find the c that we need for a perfect square trinomial. Find the value of c that makes the expression a perfect square trinomial. We're going to write the expression as the square of the trinomial. So I'm going to make a little work here. C equals b divided by 2. So b in this case is 16. Divided by 2 squared. 8 divided by 2, or 16 divided by 2 is 8 squared, which is 64. So my c in this case that I'm going to use that would make it force it to be a perfect square trinomial, 64. So I'd write x squared plus 16x plus 64. That's actually my first answer once we found c. If you see below, it says then write the expression as the square of a trinomial. So this would be what? X plus 8 squared, quantity squared. So you might want to pause the video and try letter B. For the next one, I have c equals negative 9 divided by 2 quantity squared. Now in this case, you'll see that it's not actually a whole number, and I like to just deal with it without dividing it. I think it's easier mathematically. I don't have to worry about a calculator or any complicated problem. But when you have a square here, you could simply just square top and bottom, so I get 81/4 for C. So I plug in C. And now we got to factor it. Now you might be saying, well, this one's a little bit harder to figure out, the perfect square trinomial factoring. If you go back to letter A, do you see how we had 8 here? Where did 8 come from? The number before you square it. It's like the dividing before you square it, right? So I actually go back to that step. That would be here. This would be -9 halves squared. It's a little shortcut to see the pattern behind it. Now let's put this together. Let's take example 1, example 2, and combine them to solve some problems. So you see here first, part 3, completing the square to solve quadratics. I have all the steps listed to the left, and then I have the problem to the right. We're going to solve by completing the square. Step 1, get ax squared plus bx alone. I actually might try and type this one out so it looks a little bit nicer here. So we have x squared minus 12x, and I'm going to take the 4 over as a -4. So you want ax squared plus bx alone. All right. Step 2, make sure a is 1. Where's my a? It's for the x squared. It is 1, so I don't have to deal with it. Step 3, find b divided by 2 quantity squared. Now before I actually do that, I'm going to add something here. What I like to do, and steps tell you how to do it, but I like to add the letter. We know we're going to be adding c here, right? I'm going to delete some of the spaces here. Don't forget, if you add c to the left, it's an equation. Whatever you get for the perfect square for c has to also be added to the right, because it's an equation. All right, so let's see what this is. B is -12. So -12 divided by 2 is -6. -6 squared is positive 36. All right. And you see it even says here we're going to add b divided by 2 squared to both sides. So I like adding the little c, because then I know wherever I see a c, I replace it with 36. Don't forget both sides, that's very important. When I factor the left, I now get this, x minus 6 quantity squared equal to 32. And I know now, so 5 we factored it, now we're going to solve using roots. So we take the square root of both sides. Actually, it's working out better if I type it here. I might have to add 1 or 2 things. X minus 6 equals, I'll write the plus minus in a minute. 32 we could break up into 16 times 2. Let me add my little markings here. Plus minus, don't forget that. Square root both sides. I split up the 32. And bring the -6 over as a positive. Get x equals 6 plus minus, I'll write in a second, 4 root of 2. Plus minus 4 root of 2. That's my final answer here. So do you see how we sort of combined the last two lessons, well, you'll see that in a minute, but solving using square roots from 4.5, and we combined it with completing the square with factoring from earlier in the chapter. And that's our answer. Now, I don't have to simplify it like the previous ones, because the previous ones, actually slide back, were whole numbers. Here, though, because of the root, I can leave it the plus minus. All right, so let's try another one. You might want to pause the video and see how you're doing first. In this case, ax squared plus bx is already alone. And step 2, it says make sure a equals is 1. Do you see how a doesn't equal 1 and this one equals 2? So my first step before I go is I have to divide both sides by 2 before I can even solve it. I'm going to add c to both sides already. All right, we're going to find our b. Four divided by 2 is 2. 2 squared is 4. All right. That's my c. Factor the left. I'm going to take the square root of both sides. Now, do you see how it's the square root of a negative number? It comes out as an I, right? I know I have to add this here, so you do plus minus I root 3. And to finish that, I get x equals 2 plus minus I root 3. I'm going to write that right now. And now you see the previous lesson, 4.6, with imaginary complex numbers comes back into play. All right, so for the next problem here, we're going to take the same approach with complete the square, but we're going to look at it in vertex form. And I'm going to manipulate this here for a second. F of x, don't forget, is function notation for y. When we set this up, we need to actually still complete the square. And I think the hardest part about this one is realizing the setup first, something that you just got to get used to. Now, do you see how I want to find a complete the square that'll work with a plus c here? The 3 just stays off to the side because 3 doesn't work. But I added a c here, right? Don't forget that whatever you do to one side still applies. You have to do it to the other side. All right? So then we're going to find c. I'll do it over here because it's just x squared. I don't have to divide by anything. My b is negative 6. That's coming from inside the parenthesis here. Divided by 2 squared. Negative 3 quantity squared, which is 9. Wherever I have the 9, I have to plug it back in. I need to factor. This is x minus 3 quantity squared. And I factor. And one last thing here, we want y by itself, so we're going to move 9 over as a negative 9 to the other side. It's going to get attached at the end of the positive 3. So when we simplify, my final answer is going to be y equals x minus 3 quantity squared minus 6. And that's in vertex form, right? And if I want to get technical about it, I can actually say my vertex, right? Your vertex is the inside of the parenthesis equals 0 for opposite signs. So the x is 3, and the y, or the k, is the number to the left, which is just, or the number to the right, excuse me, which is just negative 6. That's how you do the vertex ones. All right, we have one last example here. All right, for the last example here, it says the area of the rectangle shown is 72 square inches. What is the value of x? Well, if you remember back before, we have length times width equals area, right? So it doesn't really matter which one I put first. I'm going to put the 3x first. I'm going to plug everything in. And I'm going to distribute the left-hand side, 3x squared plus 6x equals 72. I'm going to use complete the square to solve it. I don't need to move the 72. The 72 is going to stay to the right already because I'm going to have to add a c to the left-hand side, right? But don't forget, if you take a look, do you see how a is 3? Just like before, we have to divide both sides by 3 first before we can complete the square. So I get x squared plus 2x equals 24. And I'm going to go back in here from here and add the plus c. So we're going to have to complete the square for both of them. Now how I get c once again, I'll do it over here. C equals, my b is 2, 2 divided by 2 squared, which is 1 squared, which is 1. So my c for this problem is 1. Where I see c for both of them, place a 1. I factor my perfect square trinomial that I forced into with the c. And I take the square root of both sides. So I square root, that's plus minus, don't forget that. So I'm going to get two solutions here, and let's simplify it because we have a perfect square. So -1 plus minus 5, -1 plus 5, -1 minus 5, which I will write out. So here's my plus minus. One's a plus, one's a minus. My final solutions, x equals -1 plus 5 is 4. -1 minus 5 is -6. And these are my two solutions for x. If you remember from earlier lessons with area, I cannot have a negative, so we crossed out that answer. So my final answer is 4, is the value of x. All right, well that's it for today. Homework, problem of the day, and then you have 4 other examples. I want you to solve them, and then we'll go over them tomorrow.